Hello, this video is going to define for you and describe the idea of polar notation.
So if you're given this vector, you can characterize it either in a polar notation or a unit vector notation. This video, as I've said, is going to end up looking at things from the perspective of polar notation.
So for polar notation, you need to know what the magnitude of the vector is, and you need to know what the angle is relative to the x-axis.
In math classes, this is normally characterized as an ordered pair. You will never use this notation in physics. So in fact, the notation that you'll use looks like this. You're going to write the magnitude, an angle sign, and then the angle relative to the x-axis. Magnitude, always positive. You're never going to have a negative sign out in front here. Okay? Orientation, as I said, always relative to the x-axis. If you want 1.5 times the vector, you're changing the magnitude. So you're going to take the magnitude and multiply it by 1.5, come up with 18. So it's going to extend the vector out by 1.5 times. The angle stays the same. So minus a, temptation is to stick a negative sign out in front of the 12, except this is a magnitude. It's never supposed to be negative. And in fact, the negative sign, you know that when you take minus a vector, what you're doing is flipping it over. This is orientation. Okay, what you've done is you haven't changed the magnitude, you've changed the orientation. So to that 150 degrees, you have to add on 180 degrees to get it oriented correctly. That's going to give you an angle of 330 degrees. Or, having done that, if you notice that this is actually 30 degrees below the axis in the minus direction, if you think of positive going counterclockwise relative to x, negative would be going clockwise relative to the x-axis as far as angles go. This angle could also be written as minus 30 degrees. So either of these two notations, this one or this one, would be perfectly acceptable. Anyway, this is pretty much what you need to know having to do with polar notation.
Aside from the fact that you have to be able to convert polar notation to unit vector notation and vice versa, which is something we'll talk about later.